Hello, and welcome to this in-depth session. In this video, we're going to embark on a comprehensive journey into advanced Python code review. Our goal is to meticulously transform what might be considered bad or un-Pythonic code into professional, highly efficient, and truly Pythonic solutions, all presented in a clear, step-by-step manner. This process is crucial for anyone looking to elevate their coding practices. This isn't merely about understanding basic Python syntax. It's about cultivating the mindset of a senior developer. We will delve into the core principles that guide professional coding, focusing intently on enhancing readability, ensuring long-term maintainability, and optimizing for efficiency. These are the pillars of robust and scalable software development. Let's begin our analysis by examining a common piece of code that you might encounter in various projects. At first glance, this code appears to function correctly, successfully achieving its intended purpose without immediate errors. It processes data and produces the expected output, which is often the initial benchmark for any code. However, the critical distinction we must make is that working code isn't always synonymous with good code. Throughout this review, we will systematically uncover several underlying issues and suboptimal practices that prevent this particular example from meeting the standards of truly professional and Pythonic development. These issues, while not breaking the code, hinder its quality. Our first and paramount area of focus will be readability. Professional developers consistently prioritize writing code that is not only functional, but also exceptionally easy to understand at a glance. This reduces the cognitive load on anyone reading the code, including your future self, making collaboration and debugging significantly more straightforward and efficient. Next, we will specifically address the issue of unnecessary indexing. Python, as a language, provides a rich set of built-in features and more direct, elegant, and safer ways to iterate over collections and access elements without the need for manual index management. Relying on explicit indexing often introduces potential for errors and makes the code less Pythonic. Verbosity is another common pitfall we aim to eliminate. Expressions such as equals equals true are frequently redundant and can be significantly simplified for cleaner, more concise, and more Pythonic code. Python's truthiness rules allow for more elegant conditional checks, reducing visual clutter and improving code clarity. Finally, we will explore and implement Pythonic alternatives that leverage the language's powerful built-in features. This includes techniques like list comprehensions and efficient dictionary methods, which allow us to write more idiomatic Python. These methods not only make the code shorter, but also express its intent more clearly and efficiently. Throughout their development process, professional developers are constantly engaging in a critical self-assessment, asking fundamental questions about their code. Is this code easily readable by others and myself? Is it maintainable in the long term, allowing for future modifications without introducing new bugs? And most importantly, is it truly Pythonic, adhering to the conventions and best practices of the language? Now, with a clear understanding of the areas for improvement, let's proceed to refactor this code systematically, step by step. Our objective is to transform it from its current state into a concise, highly efficient, and elegantly Pythonic solution that exemplifies best practices in modern Python development. We'll initiate this transformation by introducing a list comprehension. This powerful and remarkably concise construct is a cornerstone of Pythonic programming, offering an elegant and efficient way to create lists based on existing iterables, often replacing multi-line loops with a single, expressive line of code. The adoption of list comprehensions significantly improves the clarity and conciseness of our code. By expressing the entire intent of the list creation in a single, readable line, they make the code easier to parse and understand, reducing the mental effort required to grasp its functionality compared to traditional loops. Next, we'll strategically incorporate the .get method for accessing dictionary values. This method is a crucial tool for safer dictionary access, as it gracefully handles scenarios where a key might be absent, preventing disruptive key error exceptions that can crash your program and lead to unexpected behavior. The .get method offers the invaluable advantage of allowing us to specify a default value to be returned if the requested key is not found within the dictionary. This capability makes our code significantly more robust, less prone to unexpected crashes, and more predictable in its behavior, especially when dealing with potentially incomplete data. Finally, a critical aspect of professional code is the use of intent-based naming. By naming our variable active underscore emails, we clearly and immediately communicate the precise purpose and content of that variable. This practice enhances code readability and makes the code's functionality self-documenting, reducing the need for extensive comments. When we compare the original bad code with our refactored version side by side, the improvements are striking and immediately apparent. The refactored code is not only significantly more concise, occupying fewer lines, but it is also demonstrably more readable, easier to understand, and ultimately, far more maintainable for future development and debugging efforts. Ultimately, writing Python code isn't just about ensuring that the code executes and produces a result. It's about the meticulous craft of creating code that is inherently easy to read by anyone, simple to modify or extend without introducing new complexities, and robust enough to be hard to break, even under unforeseen circumstances. This is the hallmark of quality software. Embracing and consistently applying these fundamental principles of readability, maintainability, and Pythonic style will undoubtedly elevate your coding skills to a truly professional standard. This commitment to quality is a distinguishing characteristic and a hallmark of highly skilled and experienced senior developers in any team or project. If you found this advanced Python code review session insightful and helpful, and you're eager for more real-world examples and in-depth analyses, we encourage you to subscribe to our channel. Your support helps us create more valuable content for the Python community, fostering continuous learning and skill development. Continue to dedicate yourself to learning and refining your Python skills, as this continuous improvement is what transforms a good developer into a truly exceptional one. We are committed to providing you with the resources to achieve that. Thank you immensely for watching, and we look forward to seeing you in our next video.